evaluate this line integral over the circle C, that is mod z equal to 3. For this we need to find first f of z to apply the Cauchy's integral formula, right? Okay, when putting these denominators equal to 0, we get z equal to 1 and 2. We get 2 points, 1 and 2. Check whether these points lying inside this circle or not. Yes, because this circle is having the radius 3, you can take mod z to be as mod of z minus 0. So this is your origin and it is having the radius 3. And yes, 1 and 2 lies inside this circle, right? So what is our fz? So we have to take fz to be this numerator. As we have got these points which are lying inside this circle from these two brackets, right? If suppose I am having z minus 4 also, then z equal to 4 does not lies inside this circle. Yes. So for this case, we also have to include this with our fz. So the point which is not lying inside the circle, just include that bracket with fz, right? Now in our case, both the points lying inside the circle, so we have taken fz to be this only. Is it understood? Okay, let's move on to the solution. So this is the given integral having this circle. Now this integrand having the singularities, how do we calculate the singularities? By taking denominator to be equal to 0. So we are having the singularities where this denominator equal to 0 at z equal to 1 and z equal to 2. So both these points are lying inside the circle. Both these points lies inside the circle mod z equal to 3. So now we are going to apply the Cauchy's integral formula for these points. So let's take f of z to be equal to this numerator, that is cos of pi z square, which is your analytic function. So therefore, the given line integral can be written as, let's take cos of pi z square outside of this bracket. We have to make the partial fractions for this. Writing here dz. This is over the circle C. So cos of pi z square. Okay, let's make the partial fractions for this. Just write here z minus 1, here z minus 2. When considering this z minus 1, hide this. And putting this denominator equal to 0, we get z equal to 1. Put this point over here. We get 1 divided by 1 minus 2, that is minus 1. Yes? Okay. So this is negative of 1 divided by z minus 1. When considering this denominator, hide z minus 2 the same. Put z minus 2 equal to 0, we get z equal to 2. Yes? And now put this value over here. We get 1 divided by 2 minus 1, that is 1. So we can write this as plus 1. Very fine. Okay, writing here dz. Let's take this cos pi z square inside now. Now applying the Cauchy's integral formula for this. What is that? It is the line integral of fz divided by z minus z naught dz to be equal to 2 pi iota f of z naught. Now here z naught is 2, right? So we get 2 pi iota f of 2 minus, here z naught is 1. So this is 2 pi iota f of 1. Okay, what is f of z? F of z is cos of pi z square. And for this, finding f2, what is f2? Just put z equal to 2 here. We get cos of pi 2 square is 4. That is cos of 4 pi. And cos 4 pi is 1. So this is equal to 2 pi iota into 1 minus 2 pi iota. Okay, finding f of 1 now. Just put z equal to 1 over here. We get cos of pi 1 square is 1. That is cos of pi, that is equal to negative 1. So f of 1 is negative 1. So this is equal to 2 pi iota plus 2 pi iota, and that is 4 pi iota, which is the required answer for the given integral. Okay, thank you. Stay blessed.